Hogwarts. What's it like outside?
It's currently hotter than a Hungarian horntail and 56% humidity with overcast clouds.
Before we get started, this demo assumes that you already have a Rhasspy and conductor project set up along with a basic understanding of how to define a handler and service. I'll include a link to a setup walkthrough video in the description below. Okay, let's get to work. First, we'll access Rhasspy to define an intent for requesting the current weather conditions. I'll name the intent weather current and map that intent to the sentences "What's it like outside?" and "How's the weather?" After defining our intent, we'll save the changes and have Rhasspy retrain the profile. But before we switch to the conductor, let's make sure the intent is recognized. Excellent, let's jump over to the conductor. We don't yet have a weather handler and service defined in the conductor, so let's start with the handler. To recap some concepts from the setup walkthrough video, you'll see the weather handler extends the base handler, and we have our new intent, weather current, mapped. When the conductor receives an intent named weather current, our handler will invoke its current method, which in turn calls the current method on the weather service. Now let's define the weather service. This is where we'll do the work to interact with a weather API and build out a speakable response for the current conditions. As with all conductor services, we'll extend from the base service. To fetch weather information, we'll use OpenWeatherMap's OneCall API. A link to OpenWeatherMap is included in the description below. I've defined several OpenWeatherMap settings within the conductor's configuration system, such as the URL, request parameters, and the API token. The current method on the service is where we'll make a request to OpenWeatherMap's API and analyze the response to construct a speakable description for the current conditions. This method uses the Python requests library to send a GET request to the API. The API response is converted into a JSON object, and the current conditions are passed to a method called buildCurrentWeather, which is where we'll convert the JSON API response into a speakable description. Let's take a look at OpenWeatherMap's documentation to get a better understanding of the API response structure. As you saw in our weather service code, we are only concerned with the current conditions for this action. There is a wealth of information in the API response, but for this example, we'll only use the temperature, humidity, and a collection of weather conditions. Each weather condition contains a description field, which we'll use to build out the spoken description in the weather service. Switching back to our service, you'll find that the base sentence being used for current conditions contains a placeholder for both the temperature and humidity. A couple convenience methods exist to format the temperature and humidity values before populating those placeholders. The remainder of the build current weather method iterates over the weather conditions to build out the weather report using each condition's description from the API response. Before we can test our changes, we'll need to make the conductor aware of the new handler and service. Okay, let's start up the conductor and give it a test.
It's currently 55 degrees and 50% humidity with scattered clouds.
Excellent. Now let's add a bit of Harry Potter inspiration to our weather report. I'll update the getTemp description method to return a fun phrase if the temperature hits a certain high and low threshold. If the temperature is 85 degrees or hotter, instead of reporting the temperature, we'll have the system say it's hotter than a Hungarian horntail. If it's 32 degrees or colder, we'll have it say that it's colder than a Dementor's kiss. Since the current temperature in my area doesn't hit either of those thresholds, to test our change, I'll temporarily reduce the high threshold to 50 degrees. Let's give it a try.
It's currently hotter than a Hungarian horntail and 56% humidity with overcast clouds.
Fantastic. It seems to be working fine. Now let's step it up a notch by adding some sound effects. It's currently raining in my area, which makes it a perfect time to add sound effect functionality. Open Weather Map organizes weather condition codes into groups, such as thunderstorms, drizzle, and rain. We'll use these code groups to conditionally play a weather sound effect while the conductor speaks the current conditions. I've already staged some example sound effects in the conductor's resources directory. We'll define an effects dictionary in the weather service which maps weather condition codes to a collection of sound effects. Next, we'll update our build current weather method to keep track of all condition codes that are returned from the weather API. If we inspect the conductor's response class, we'll find that it supports specifying an optional background audio track, which will be played along with the text-to-speech audio. To get the appropriate sound effect, we'll define a helper function to analyze the collected codes from the current weather forecast. For this demo, we'll keep this method simple and just return a random audio track for whatever the first condition group is that we encounter. Now we simply need to call that function to populate an optional audio track in the response object. Let's give it a try and see how it works.
It's currently 55 degrees and 78% humidity with heavy intensity rain.
Fantastic. Now we have a digital assistant that can report the current weather conditions, mixing in some fun Harry Potter inspired descriptions, all while playing sound effects. I hope this example inspires you to experiment with building your own unique digital assistant. Until next time, peace.